Welcome to Study Loop.
Our question says that when Babe Ruth hit a homer over the 8.0 meter high right field fence, 98 meters from home plate, roughly what was the minimum speed of the ball when it left the bat? Assume the ball was hit 1 meter above the ground and its path initially made a 36-degree angle with the ground. So I wrote out what we were given here just in the beginning of the problem. The fence, which I write as y, is 8.0 meters. The initial height of the ball is 1.0 meters. The angle it makes with the bat is 36 degrees, and the x distance it's going to travel is 98 meters. So then the question, what it wants us to figure out is the velocity when it leaves the bat, the initial velocity, or v naught. Well, let's just kind of start writing out some things we know with the equations that are very common equations. Well, one thing we know is distance, which is x, is equal to the velocity in the x direction times the amount of time that it spent, okay? But the velocity in the x direction is equal to the initial velocity times the cosine of theta, right? We can put parentheses around that because that's v of x times the time. Okay, so we know x in this equation, we know theta, but we don't know time, and what we're trying to find is v naught. So what other equations do we have, which also include theta, which include time, and which include other values which we have? Maybe we can use those to solve for time in terms of things we do know, and then in turn solve for v naught. Well, we know that y is equal to y naught plus the velocity in the y direction initially times the time plus 1/2 acceleration in the y direction times the time squared. Okay, well, we can rewrite this as y naught plus v naught of y is also v of 0 times the sine this time of the angle, theta, times the time, okay? But what is the time? Well, we just, if we look at the equation above, time is equal to x divided by v naught sine theta, right? Well, what if we plug that in here for time? We'll end up with x divided by v naught sine theta. There's a theta here. Or I'm sorry, that was a cosine, wasn't it? This is cosine theta, not sine theta, because this is x. So let's just erase this because this is cosine. Rewrite this as cosine. Okay, so here's cosine theta. Okay, which is really convenient because the v naughts are going to cancel out, and we don't know v naught. So those are going to cancel out. So we don't have to worry about that. Plus 1/2. Okay, a of y is gravity in the negative direction, right? Because it's acting in the negative direction. So we can just pull that negative out front. We can make this plus a minus. So we'll turn this into a minus. So it's going to be minus 1/2 of gravity, minus 1/2 g, times t squared. Okay. Well, we're not going to replace the x over v naught cosine theta for t here, because what we're really trying to find is a value for t that's an actual value based upon what we know, which we can then use in the first equation that we have, which I'm just going to mark by a little green star so you know which one I'm talking about here. What this equation, if we know t, we know x, we know theta, we can find v naught, which is what we're really trying to find here. So let's rearrange this equation. The second equation, which I'll denote as a red star, okay? Let's rearrange that equation now in terms of t, because we know everything else. Okay, so if you do that, you're going to find t is equal to, well, this is t squared, right? Because the t is squared, is equal to, first thing is y minus y naught, okay? So we have y minus y naught, okay? And then this is going to be we have, because there's a minus sign in front of the t squared, right? Because it's minus 1/2 gt squared. So we'll keep that over here. We'll have minus 1/2. We'll just do this one step at a time. Gt squared is equal to y minus y naught minus the v naughts cancel, as I previously showed. We have x times sine theta divided by cosine theta. Well, sine theta divided by cosine theta is tangent theta. So this is minus x times tangent theta, okay? And we're trying to isolate the t, right? So, well, it's divide by g. So the g is going to get canceled out on that side, and you're going to have divided by g on this side. We'll multiply by 2, and let's multiply by minus 2. So it gets rid of that minus sign too. So then this becomes a plus, and that becomes a plus. Then to get rid of the square root, we take the square root. Or to get rid of the squared term, we take the square root. So this is what t is equal to. T is equal to 2 times y plus y naught plus x tangent theta, all divided by gravity. So if you plug in the values we have for those, gravity is 9.8 meters per second squared, y is 8 meters, y naught is 1 meter, x is 98 meters, theta is 36 degrees. So you plug all those values in, and into this equation, you find that this is equal to 3.620 seconds. Okay, so now we have an actual value for t. So we can go back to the first equation, which I denoted as the green star, which says that x is equal to v of x times the time. Okay, so x is equal to v naught cosine theta times the time. Okay, and v naught is what we're trying to find. So now let's solve this equation for v naught. V naught is equal to x divided by the time times cosine theta. Okay, so now we'll plug in 98 meters for x, what we just found for the time, 3.620 seconds for the time, and 36 for theta, and you'll find that this comes out to be 33 meters per second for the initial velocity of the ball off the bat.